Okay, we're going to write the equation of a line in the slope-intercept form that's perpendicular to this line, y is equal to negative 3 over 5x plus 1. And we also want to have the point 12 comma negative 1. Alright? So remember, first of all, we have to know what slope we are going to use. So the condition here is that we want to have the line to be perpendicular to this line. With that being said, you have to know what's the original slope for this line, right? And let me just write it down right here. It's given that y is equal to negative 3 over 5x plus 1. This is pretty good because this equation is in the slope-intercept form already. That means this right here, the coefficient of x, the number in front of the x, this right here, it's the slope already. So that's the original slope for the original line, which is negative 3 over 5, right? However, if you want a line to be perpendicular to this, once again, this is just a given line. That's not what we want. If you want to get what you want to have, you want to have a perpendicular, you have to use the perpendicular slope. And this is the notation for the perpendicular slope, right? Okay, so what you do is that you do the opposite sign. Since this was negative already, the perpendicular slope is going to be positive. And then you do the reciprocal. So instead of the 5 on the bottom, you will have the 5 on the top, and then the 3 on the bottom. So in fact, the perpendicular slope, 5 over 3. Positive 5 over 3, this is the slope that we are going to use, right, for the perpendicular slope. And now, here is the setup, okay? We are going to use the point slope form to set up. We have y minus y1 equals to, usually I will just write down m, but this time just let me emphasize that we have to use the perpendicular slope. So I'll put down n with the perpendicular symbol like this. And we open the parentheses, x minus x1. And now you may be wondering, what's x1, y1? That's just the given point. And we do have that right here, right? So let's go ahead and label this right here, it's my x1, and this right here will be my y1. And now we are all ready to plug in all this value into this equation here. So first we have y, this y in black stays, and then the minus, y1 is negative 1. So I'll put down negative 1 right here with the parentheses. You see, this negative was from the formula, but then the minus 1 is from this value y1, okay? And then we have this equal to the perpendicular slope, which is positive 5 over 3. So write this down right here. And then parentheses, and then the x, and then the minus. x1 is what? It's given to be 12, right? So just put down 12 right here. Aha, that's the setup. Now, remember, for the slope-intercept form, we have to have what? Y is equal to mx plus b, isn't it? The y has to be by itself. We just have to work this out now. First of all, we have this. Y minus minus becomes plus 1, like this. And then on the right-hand side, you see there's no parentheses. We have to take the 5 over 3, distribute. 5 over 3 times x is just 5 over 3x. And what's 5 over 3 times negative 12? Well, we know the result has to be negative because positive times negative is negative. And how can we work out 5 over 3 times 12? Let me just show you real quick on the side. 5 over 3 times 12, and we'll put the 12 as 12 over 1, okay? And you have two ways to do it. You can just do 5 times 12, which is 60, and then divide by 3, which is going to be 20, okay? Or you can just cross-cancel, cross-reduce first. You see that 3 goes into 3 one time, and 3 goes into 12 4 times. And that's what we can do, right? And then 5 times 4 is 20 over 1 times 1, which is over 1. Doesn't matter. Anyway, 5 over 3 times 12 is 20. And it's a minus 20 because positive times negative is minus, like this. At the end, since this is y plus 1, so let's minus 1, cancel this out. And we will have the y, and that's equal to, this is 5 over 3x. And you see how we put down numbers together because we can combine them together. Negative 20 minus 1, that's negative 21. So therefore, y is equal to 5 over 3x minus 21. This right here is the answer for the line with these conditions. That's it.